Hey folks, welcome out there. I got help today, all right? And some of you saying you need help, Ernie, I tell you. But welcome to our Mathline show this afternoon. Gary Petco, my co-host. I'm Ernie Roberts, your host for the afternoon session. We're going to work some math problems, hopefully, that you call in and give us, all right?
Yes.
That number, 844-686-2378. Gary's giving it his time. I'm here. You always have to put up with me, but I appreciate Gary coming in and taking care of things today. Math supervisor for Knox County Schools here in Knoxville, Tennessee, and wealth of knowledge, wealth of resources.
Oh, thank you for letting me be here again.
Hey, we're glad to have you back again. Always glad to have you back. You know, we've got kind of an interesting week because this is Trick or Treat Week, it's Halloween, all sorts of good things. So, folks, I want to put a quick plug in for Thursday night show. We're going to be doing our annual Halloween. It's an encore presentation. We hope you'll enjoy it. You don't want to miss out on that. It's something a lot of fun. If you've seen it before, it's worth seeing again, all right? And speaking of which, let's go ahead and look at problem of the day.
Let's do it.
While you're calling in, 844-686-2378. Halloween candy sale. A bag of 5 miniature candy bars sells for $4.50, while a bag of 70 miniature candy bars sells for $6. Which is the better deal per candy? All right, Gary, we've got an interesting look here. It's kind of one of those which is the best buy kind of thing. And we're going to assume that you really you want to buy a lot of candy probably,
Sure.
Okay? You're anticipating a lot of trick-or-treaters. So we've had some interesting comments, not comments on Facebook, but it's 50-50 right now, all right, as our choices for which way we're going to go. So we're going to check it out and see how it happens. And what would you suggest? What's our first best thing to do?
Well, I'm thinking ratios, thinking unit rate.
Well, all right, so what are we going to set up for our ratio? Find a unit rate. Sometimes we see 4 numbers here. What do we want to do with those 4 numbers?
Well,
I've got 50, $4.50, 70, and $6. Tell me what you think.
I think the 50 and the 450.
All right. How would we go? Would it 50 over 450 or 450 over 50?
Well, that's
a lot of 50s, isn't there?
Ooh, I think the fun part doesn't matter as long as we're consistent.
As long as we're consistent.
Let's go, since it's in order, let's go left to right, 50 over 450.
Want to do 50 over 450? Yeah. Okay. Now, what are we going to have happening here then? What is this telling us then? Because we have basically the bars over the price, right?
It is. So and that's what I love about this. Is when you as you're more and more precise when you put the units on there, it allows us to see. Maybe it might be clear if we put the 450 over the 50.
Well, and
price per bar.
And I think that would be the case because a lot of times, and when students and adults, likewise also out there, see a lot of words, they begin to think, oh, it's all left to right. It's going to be in that manner. But this one, we got to stop and think a little bit.
Yeah.
And the 450, I agree, because what are we looking for? We're trying to say which one is the better deal, better price.
Per bar.
So I like that. So you say put what?
$4.50 over 50.
Okay. So let's just go ahead and say, we'll run that out of there. If you want to go some other problem with that, you probably can, folks. But at this point, what we're after is really the price per bar.
That's where those units come in so handy.
Aren't they great? Yeah. They are. And that's another important thing because all this math we learn has got to be about, it's to be applied, to put out there. And so this is an application for Halloween, nonetheless.
That's
all
right.
So let's figure it out. What are we going to get? Should we go calculator?
Division, yes.
You want to do calculator on that? All right, let's go to the calculator, guys. $4.50. We're going to divide because that's what a ratio says to do. So many times people forget that's what a fraction is all about.
All it is.
It's just division. And how many? 50.
50.
Whew. Pretty good. All right, we're paying 9 cents a candy bar.
9 cents per bar.
Oh my goodness. Okay. So this is going to be the price. And basically we got a 1 bar, right?
That's exactly right.
So I'm going to keep it a ratio, but we know what we're saying there. It's 9 cents, okay. All right, well there's our first one. Ha-ha. Now, I guess we need to do the same approach, right?
We have the exact same approach.
So tell me where we're going to go here on this one, since you set this up.
Same way, we're going to have the price over the bar, so $6 over 70.
I'm going to put, just for those who maybe just joined us, I'm going to put a dollar by that thing. And this is cents, okay? How about over 70? I'm looking at that. Those are, we could have reduced those fractions too. But
sure could
that's
have.
another story. But since we did, let's go ahead and stay on this. I get a little ADD at times here with the $6.70. So you said we'll do the calculator again. How about it? And folks, we don't really have to put a decimal 00 on there because $6 and $6, it means the same thing. That's the nice thing to think about there. So let's go with 70 and see what our money value is here. Well, it's pretty close, to be honest.
It's real close.
It's real close.
For one bag.
Yeah, and actually, you're going to pay a little bit less, just a tad. So this one really came out interesting. So let's make it, folks. Let's make it. See what we're going to have. I'm going to just take it to, first of all, just 4 decimal places. And folks, remember that is. We're going to be talking about cents, so we're going to need to do what, Gary? Kind of play a round-off game?
I'll tell you what I really liked about that. I love the fact that you put the dollar sign there. That's exactly what it is. It's 8/10 of a dollar. Or 8/100 of a dollar, I'm sorry.
8/100, yeah. So if we've got the dollar, or as we like to say, 8 cents, we're going to have to pay a little more, it looks like.
That's right.
So, but just a tad more. Basically, it's more like taking 8.5 cents each one. But so we are getting a little bit better deal there. No wonder we have
with one bag. But as you said earlier, if you're buying a lot of bags, that's going to save you more.
It saves you more in the long run, right? For one bag per se. And I know there are some places in our area that will have thousands of trick-or-treaters coming to their houses.
Absolutely.
So they really do look for the better deals there. As for my house, that's probably more like 70 or 50 we'll see coming through, and that's weather permitting. We're hoping for some good weather on that. So keep those, and by another place, those percentages are going to be helpful. Finding this probability of precipitation on Halloween. I'm sure we're all getting excited about that and wanting to make sure we stay dry, hopefully. Well, we'll see how that one works out. But anyway, that's our start today. Folks, we need you to give us going, all right? Give us a good old call, 844-686-2378. We are here on Mathline. We're going to do some problems, but we would like to hear from you. You give us some problems. You give us what you think you'd like to hear today. I'm going to pick up with one thing that we did from last Thursday. Got cut off in it a little bit, but we got it through. But I want to finish it per se, and you'll understand what I'm talking about. Those of you who were with us last Thursday, those of you who weren't, hey, here you go. Let's see what happened here. Let's see. I had this problem given to me by one of our callers here. It said negative 3x, and it said plus 5. And we're going to take a greater than negative 16 approach here, all right? And basically the deal was, let's solve and graph.
And graph.
Solve and graph, all right? So both things we're looking for. And there are a few little tricky moments here because it's all about, and so many times it's about a negative, but we see another negative. And we sometimes don't know when to work with our negatives, right? So, Gary, first step, what is our story on this one?
That's kind of a two-step inequality. I'm going to isolate that variable.
Well, let's go with
get the 5 off.
Let's do that 5. I think it's what our caller we did last time.
Correct.
All right. So I'm going to put it over here, and you hear me talk about the addition, subtraction, multiplication, division properties of the equality. Well, this is a property of inequality because we're working with the greater than situation, and we're going to subtract the same thing off, but it doesn't matter. We're still going to have this negative 3x. We're going to still have negative 21, and this is where we get to the moment. When we add or subtract, that does not shift the inequality, right?
It does not change.
So we're not ready to move that yet, okay? We're going to keep it at greater than. Keep it greater than. Now comes the moment. We are going to deal with the negative 3 on this position. And when we go back here, what are we going to do?
We're going to divide.
We've got to divide, yeah. And it's a different story when we divide by a negative number rather than when we subtract a number from both sides. We're going to get a different story, especially when it's a negative. If it's a positive, life is good.
We're good.
No problem. But the negative basically tells me everything is just, all the signs have just changed, which basically means that inequality has to shift. Because whatever was the setup, which was greater than, by changing the signs, we've turned it completely around. So let's go to x less than 7. And let's see. we just made a big difference here, my friend.
Absolutely.
Because what happened, we said we're going to solve and graph. Well, there's the solving part. So let's do a quick number line here, and then we're going to check. Always like to check. And we're at 7, so I've got an open circle there because we don't want to include the 7. And folks, we can kind of put that 7 anywhere on the number line we like, but the idea is which direction are we going to shake?
Correct.
That's what's important to us. And where are we going? According to less than, it says go left.
Left, everything below 7.
And we keep that open circle. We shade right up to it. And that open circle looks kind of exaggerated, but it's there to know that it isn't included. We don't include the 7 because if we put a 7 in here, we're going to get an equals situation. Well, maybe. I think we would. Yeah, put a 7 in there. If we did it right, we did. And we get negative. So we don't want 7. So let's try something to check with. Let's go back to our little problem here. It says negative 3x. We didn't get a chance to do all this on Friday. We just got it set up and got a solution and didn't even get to graph. But let's go back to the beginning, because how do you check an inequality? Because we've got basically an infinite number of solutions running loose over here.
Well, it looks to me if we try any number on the left of that 7, if one of them works, they have to all work.
Absolutely, that's true. Because we know that boundary is set because we went back and said, well, if we put a 7 in there, it's equals.
That's right.
So we know that much is true. So pick maybe 6.
Yeah, I'd probably choose 0. I'd choose 0.
0 is even better. Yes. Yeah, because it's still in that shady land. Okay. So let's put a 0 in there and see what we get, folks. There's one place to put it, right there. So wipe out.
That's right. It's even easier.
5 is greater than, and that's why we choose 0, because we look for things that'll go away like that. And is 5 greater than negative 16?
It is.
It is. So easy check. If we had not changed, and a lot of times our students forget to do this. A lot of times our adult viewers probably forget to do this. If we kept greater than, if we put a 6 in there, my friends, we would have a statement that was not true.
Absolutely.
We would get negative 5, well, let's see, what do we have? Negative 24. If we put in 8, I'm using 8. Sorry, I was kind of thinking in my head a little bit there. And then add 5 to that, we get negative 19, I believe. And negative 19 we know is not greater than negative 16. So again, that's how we check. You just pick a number, a nice whole number. Doesn't have to be complicated. Doesn't have to be the number that's like right there at 7, like 6.99992 or something like that. No, make it easy.
Anything in that anything in that little range.
And the 0, I like that idea. That's a good way to go there. So there we go, folks. A little bit of look there into our caller who from last Thursday gave us that call at the very, very end. I hope that finished it off for you. I know I asked him to stick around for a little bit. He didn't, so I assumed he had what he needed from the solution we presented. And hey, now what we need to do is hear from you guys. 844-686-2378. Give us the call and let us hear from you. All right? We want to have some fun. We've given time. We're here. Gary's given his time today and to help us out. Also, our phone operators out there are waiting. Let's put them to work. All right? 844-686-2378.
Yep.
And Gary, I think you got a problem over there we want to look at.
Problem. Oh, for you algebra folks out there.
This is a little algebra moment here. That was kind of a pre-algebra moment.
That was pre-algebra, yes.
Yeah. So 7th, 6th, 7th, 8th, middle school type thing. This is going to take us to the high school, folks.
Love it.
All right. And let's see what we got, guys. Here we go. It says solve the quadratic equation. Oh, that means there's x squared, doesn't it?
That's a quadratic. That's right.
And then check both solutions. So what we're going to do here, we're going to save this space over here for checking time, all right? And we're going to see what we can do with this little guy here. Now, when we think quadratics, there are a lot of ways to solve. What are some of our options that we've got?
Factoring, quadratic formula,
right?
completing the square,
Woo, yeah.
graphing. Ooh, we got a lot of ways.
My. You know what? I'm thinking maybe we want to try factoring first because these numbers are not that outrageous.
No.
And I see something that's going to help us. You see something that's going to help us because you brought this problem with you, I bet.
Right.
All right, so let's see. First trick, my friends, what do we do?
You know, whenever I work with quadratics, I always isolate, put everything to one side.
Okay.
All the expressions to one side.
All right, so we're going to move, we got to move the 8 then.
Right.
All right, so let's see, do a quick subtract 8 here. And we're going to subtract 8 over here because, we're back to that subtraction property of
That's right.
equality this time. So just a quick drop here. And I want to, folks, I want you to be careful here, and Gary's going to say the same thing. We're picking up a 0 over here. Sometimes people are, Well, it disappeared. What do we do? Well, that's what zeros are good
That's
for.
exactly it.
That's why we like them, all right? So we'll put at -8, gives us 0 there. But over here, you got to be careful because I'm seeing 4x squared leading the way. Can't mix it with -4x. They are not like terms. But you know what? That -8
is still there.
And let's bring it in. Do we make -12x there?
No, because those aren't like terms. Negative 4x.
Very
and then,
good. So we're going to keep them separated. That's another mistake that a lot of our algebra students like to. They think they've got to put everything together, but no. They keep it separated, and then they're going like, that still doesn't look any better, does it?
And I like this problem.
Yeah. Now, Gary, temptations. What do you think?
Oh,
We're going to factor?
yeah. When I look at all those, the 4s and the 8s, I see some commonalities. I want to factor out a 4.
I got you on that. I feel you on that. Yes. So we can divide 4 out of each of those, pull them out. And do we take an x with it?
No, because they'd all have to have an x.
We got to be careful because sometimes you get gung-ho about that 4 and you think the x is supposed to go, but we don't have we don't have an x involved with the 8, so we got to stay with the program, so to speak here. So we're going to pull out 4, and all of a sudden things start dividing out very nicely in there.
Really good.
And I'm going to leave a parenthesis about it because this is what we call our infamous GCF. We love that, greatest common factor. And what's left behind, Gary?
It's an x squared right there.
Because the 4 is divided out.
Divided out.
Okay. And here we have what?
I say subtract an x.
And keep that subtract symbol.
Right.
Don't change it.
And then subtract a 2.
All right. Ooh, I like smaller numbers.
Oh,
They look
see,
so
that's
much nicer. And we still have that equals 0 hanging on.
Right.
Because, folks, it's in order to solve, you've got to have an equation. You've got to have an equal somewhere in there. So we got to keep that in. So the 0 is still important. It has not gone away, and it's going to stay with us. Now, this little 4 out here, some of you go like, is that important? We'll talk about that in a minute,
Absolutely.
okay? Let's keep it for right now, and let's break open, since we're going to try to factor, and let's take a look at it. I see I have to multiply to get a -2. So I'm thinking plus and minus.
Yeah, I see opposite signs.
So we're going to go ahead and put that plus and minus. That helps a lot because students, a lot of times, that's the hardest thing is what sign do I put down?
Sure.
You know, and x squared, we can get that pretty easily,
That's
right?
right. That's an x and an
Let's
x.
come in x times x here. Because folks, that's what we want to do. Go back. It's kind of doing that foiling, that distributive property. Go backwards. X times x gets us back to the x squared, and that's what so it's an easy start. And not many ways to multiply get 2.
So that constant's pretty easy. So I've got a 2 and a 1. And since signs have to be opposite and I need to have a negative x, I think it needs to be an x plus 1 and an x minus 2.
Because what's going to happen if I look at my inner and outer business here, I'm getting a negative 2x and a positive 1x, which gives me a negative x, which is the same thing as 1x, my friends. Those of you who are wondering, well, what's in that middle? What does that mean? There's like a 1 there, okay? So we're playing with that. We're going to work with that. So at this point, you say, okay, what have we done? Well, let's see. What have we done? We are ready to, I think, find out what x equals.
That's right.
And how about this 4? Wait a minute. Is that a solution?
No, it's not. Solution is something we need to solve for, which means something has an x.
So if I had 4x, I would have a solution.
Absolutely.
But I don't have 4x, so...
It's just a constant.
All right, so here we go. X plus 1 equaling to 0. On the other side, we have x minus 2. Also, I guess
Equals 0.
Why did we do that?
That's a great question. Fun property called the zero
Because some of us
product
were going,
property.
where the heck did that come from? And notice the 4 we said we're not going to worry about it, right? Because there's not an x attached. We can divide 4 into 0, go 0 times. So it's just kind of like, goodbye.
It's just
but
pure,
this is what's important.
it's just pure numbers. If I've got two expressions, if I multiply together equals 0, or if two numbers equal 0, when I multiply them, one has to be 0 or the other.
Okay, absolutely. So we're looking for 2 possible, it says both solutions, so we're
Right.
looking for 2 answers here.
Right.
In this case, there are 2 distinctly different answers going to be. And it's pretty easy because we can think at this point, and most of our students and folks who are at this point say, oh, I got that. It's what plus 1 gives us 0. It's the opposite.
Right.
So it's a -1. And we've been doing that kind of stuff since first grade with the x minus 2 business. So x would equal 2. And there are 2 solutions. How about that? All right, how about it? Should we check?
We got to check.
We got room. So let's pick it back up here. By the way, we go back to the very, very beginning. We don't skip into the middle of the problem.
That's
we
a
check.
great point right there.
Because
Great point.
the whole thing is, if we've made an error, it's very possible we may have forgotten to take 4 out of each of these numbers.
Correct.
You might have come out with, x squared minus x minus 8, which wouldn't factor anyway. So, but you get, but that's the important thing, is to go back to the very, very beginning. So let's pick it up. Let's do -1. Why not? Substitute. It's substitution. Wouldn't we call it?
Correct. This is looking good.
Equals to my 8. All right. I have. Well, negative. Oh, here's another place where we like to mess up if we plug that in the calculator. Heaven knows we don't like to do that in the calculator. But it's a negative times a negative because we forget to put parentheses around it. But it's going to give us 1, so that's 4.
It's 4.
And this is going to also give us a positive because it's basically a negative times a negative. And I believe all of our folks out there are going, oh, that's easy. We can say that 4 plus 4 equals 8. That checks out beautifully. So let's try our 2. Let's try our 2. 4 times, that was our other solution, yeah.
2 squared, yes.
2 squared. Minus 4 times our 2. Do we still get 8? I'm seeing 16 here.
I'm seeing it. I say we do.
I'm here 8.
Subtract 8.
Equals to 8. I believe we got it. 8 equals 8. Solution, John.
That's right.
Good job, Gary. Good
I love it.
problem. Now, you mentioned something about graphing. These people out there know I love the graphing calculator.
You and me both.
So let me go back over here a minute. Yeah, let's do graphing calculator. I think graphing calculator would be great. So let's get rid of that one. That's not where we are. That was another problem we had earlier this week. And I'll have to tell you about that one again here sometime there. How about, let's see, let's go with keep the 4. And we'll do 4x squared. And I'm going to go ahead and let it be set equal to 0. How's that?
Okay, I like that.
Because I think we're going to have, we need, it's just going to make it quicker and easier. And that's what I tell my students to do. All right, where's my x? There it is. Come on, baby. And we'll put -8, didn't we, when we pulled it in there? All right. And the whole idea is we're going to see a visual of what this thing is. A lot of times people wonder, well, what's the purpose of those things? And here we go. We graph. Holding my breath here. Oh, I got some points there. I need to get rid of those guys. Let me get rid of those just a second. That's stat plot, y equals. Let's go back to, if y'all just hang on for a minute, we're going to get to, let's go second y equals. I just need to shut that off. We were graphing some things earlier, Gary. That was the thing. So let me go back here, enter, turn it off. And sometimes those things happen, folks. That's the same thing our students go through. Now let's go back to y equals, and let's see if we get that. Yeah, we don't have those little red polka dots kind of coming up there. But there is an important thing to notice here. Right there, those are our numbers that are in question, -1. Looks like it's crossing the axis. Crossing that x-axis, and there's 2. And what's going on there? We're getting the value of what?
That's when it's equal to 0.
Equal to 0. And that's another nice way to check. And honestly, it's a nice way to find solutions.
Visualizing it, yes.
Absolutely. And just for those who, I love to do this thing. Everybody knows I love the trace. Well, there's 0, -8. That's not, we're looking for a y equals 0.
Right.
So I've got -1 popping up here. And the question is, when I hit enter, will it go to? Yes, it will. You'll take it right there, and you see it right there. Folks, it's nailing that x-axis very hard right there. Now, what about our other little guy, 2?
There it
Ta-da! Works again. So easy check, right? And Gary, you recommend the graphing calculator?
Absolutely.
On that
That's a great tool to visualize concepts. Nothing wrong with it at all.
And a lot of people feel like that takes away from the the math experience, but I disagree. I think it's a great way to enhance it, and especially if you keep it in context and they understand, oh, this is where this is going to and such.
Correct.
There. So, but anyway, that was one of those things. I'm glad we got to show that one there. And again, that's kind of what happens on here. We look at different options for solving problems.
That's right.
A lot of people think there's one way, the quote, one size fits all. Doesn't always work that way. And in that case, you mentioned the quadratic formula. It would probably be the next best way to go after these two. And then also, what was it? The completing the square looked a little complicated to me.
I think we have a lot of adults that say, why don't we just show them one way?
Right.
I think we want to show them multiple ways, and then based on the situation, figure out what's the most efficient way.
And that's part of teaching them to think.
Yes.
Think for themselves. What's the best way to go after a problem? There are many multiple ways to solve. But that's part of it, looking at, okay, what am I comfortable with? What do I do best? All right. So, folks, we have come to almost the close of our show here, and got a little algebra in, got a little bit of Best Buy, mental math, some elementary school stuff, and we have the middle school in there with
That's
the
right.
quadratic, not the quadratic inequality, but just good old inequality, and watching how to check those. One of the things we want to make sure we understand is checking your work is important. Some people think that's a drudgery, but really it's very important.
Let's double check it, yes.
Double check, because that's how you know that the solution is going to work, and it makes you happy to see that, I think, too. Gary, thank you for being with us again today, and always good to have you on the show.
Yes.
And you know what? We'll be back again live this week, like I said, Tuesday and Wednesday. Thursday night, you want to tune in for me and my co-host Jack. Okay, Jack the Jack-o'-lantern. It's going to be fun. You don't want to miss out on that. And that's for those of you who aren't out trick-or-treating. And if it's dry, go trick-or-treat. If it's rainy, hey, watch Mathline, okay? And thank you, Gary, again, being with us. And we will see you once again next time.